All right, this problem is asking us to fill in reagents and structures products where necessary. So it's just a synthesis scheme. It's not a full-blown synthesis problem, but it is along that line. So you do have to know reagents and you have to know the products that they make. And so let's take a look. The first one is SOCl2 and pyridine with a secondary alcohol. Well, what we should know is that's going to do a substitution reaction, specifically an SN2 reaction. So we have to go back to our SN2 knowledge, and we have to remind ourselves that that means there's going to be an inversion in the stereochemistry if there is stereochemistry. Here we do see stereochemistry, and so we'll get an inverted stereocenter. Now, what's going to substitute? When I react SOCl2 with an alcohol, I substitute the OH for a Cl. And so that's what the product is there. Now let's take a look. It seems like I've taken that Cl and I formed a double bond with it. So I eliminated it. Now I also eliminated it in the least substituted position. So that's Hoffman elimination. So we can do something like DBN, DBU, tertiary butoxide, some large, bulky, sterically hindered base to get us the Hoffman product. All right, so now I'm going to react that double bond with in hydroboration oxidation. So BH3THF in the first step, then hydrogen peroxide and sodium hydroxide in the second step. That again is going to form an alcohol. The question is where is the alcohol going to form? The regioselective outcome of this alcohol is that it forms in the least substituted position. So I will add an alcohol across the double bond. I'm adding water across the double bond. The OH goes in the least substituted position. All right, let's take a look at the next reaction. What's happening? Oh, it looks like I'm going from an OH to a carbonyl group. And so I do need to identify that as an oxidation because oxidation tells me what reagents I can use. I can use PCC and CH2Cl2, or I can use sodium dichromate, chromic acid reaction. But the question is how oxidized does the carbon become? We notice that we only get an aldehyde. And so I can't use the chromic acid reaction because the chromic acid reaction of sodium dichromate will oxidize the carbon as far as it can go without breaking any carbon-carbon bonds. And so since this is a primary alcohol, it could theoretically oxidize all the way to a carboxylic acid, but we notice that it stops at a carbonyl group. So that means that I need to use something a little bit weaker like PCC. So I need to use that as the reagent there. Finally, what do we have going on here? We've got reagents that look like the Grignard reagent. And Grignard reagent is going to react with carbonyl group in a fashion that turns it into a hydride. And so I'm going to get the methyl group that's going to add to the position of the carbonyl carbon. That's going to leave me with a negative charge. Then the H3O plus will reprotonate the alkoxide and form the alcohol. Now, from a stereochemical perspective, you could theoretically get both versions. So it could be both versions of the stereochemistry that show up. In other words, the Grignard reagent could add from both sides of the planar carbonyl group, and so you get both versions. But that's it for this reaction scheme. We've got it accomplished.